So on Friday the 11th, we started doing level 3 of the distance grid together in class. First, we did a few warm-up problems, so let's try those together. Take a look at these. I'd encourage you to pause the video first and see if you can work out an answer for them. We talked about how to do the first one already, but the second and third are again review from middle school. Now, as for the first one, finding the length of that blue segment, I can't count the boxes very easily because it's not horizontal or vertical. So I would want to think about drawing a right triangle and making that be the hypotenuse of the right triangle. So here with my mouse, I'm imagining drawing a right triangle, connecting the endpoints, and you can think about what would be the lengths of those sides. If I just kind of eyeball it here with my mouse, it looks like this horizontal side has 1, 2, 3, 4, 5 boxes, and it goes up 3. So I've got a right triangle with side lengths of 5 and 3. When we do the Pythagorean theorem, 5 squared plus 3 squared becomes 25 plus 9, which is 34. We take the square root of 34 and I get approximately 5.8 for this blue length. 5.8 is the rounded answer. Square root of 34 is the exact unrounded answer. So that's an example of a level 1 type problem that we tried together in the last video. Now for area and perimeter. This is the reason why we are learning about the distance formula, is to be able to calculate areas and perimeters with coordinates on graphs using things like the Pythagorean theorem and the distance formula. So the area of a triangle. How do I find the area of a triangle? Well, it gave us this 4 and this 6. If you don't remember how to do the area of a triangle, imagine that this triangle here was inside of a rectangle like this. We should hopefully know the area of a rectangle formula. It's just the base times the height, or the length times the width. Let's call this distance here the base and the vertical distance the height. The 6 is referring to the whole base and the 4 is referring to the height. So I can just take 6 times 4 and get 24 for the area of this whole rectangle. This triangle, it's kind of split up into 2, right? And the one on the right, I could fit where it is and right next to it in this empty white space. Same thing with this triangle on the left. If I were to rotate it around, I could stick it right in that top left corner. What that means is that this triangle is taking up half the space of the rectangle. So the area of a triangle formula is 1/2 the area of its rectangle, or 1/2 base times height. So we can simply take 1/2 times 4 times 6, which is 24, and we get an area of 12. So the area of a triangle is 1/2 times base times the height. A rectangle is simply base times height. As for the perimeter is the distance that a shape has in terms of going around the edge. It's how far the distance goes around the edge of the shape, simply put. So this 5-sided shape we call a pentagon. I can just add up the lengths of each side there to get the perimeter. And when I add them all up, we should get 19. So that's the perimeter, not too complicated there. So what we are going to do now is you're going to go to level 3 of your distance grid, and we are going to try this together. What we did in class was we looked at these shapes and said, which one has the most area? Which one's the biggest? And we took guesses. We figured out who thought each shape was the biggest. It was pretty evenly split among them all. A lot of people said that the triangle, the orange triangle, had the most area. So it's hard to tell without having a graph or a grid or coordinates. When we put these on a grid, like you see on page 7 of your grid, now we can use some Pythagorean theorem and distance formula stuff to figure that out. So here's what we did in class on Friday. We took a look at each shape, and we'll start with this orange triangle. So we talked about how the area of a triangle formula is 1/2 base times height, where the base and the height are perpendicular to each other, or they make a right angle. So this top left and this top right side, that's our base and our height, because this right angle symbol is telling us they meet at a right angle. So that's good to know. Question is, I don't know the base and I don't know the height because they're not easy to measure like the ones for this green trapezoid here. So we have to do some distance formula or Pythagorean theorem calculations to get side lengths. So here's how we did that. right? Imagine a right triangle for that top edge, you're calling the base or the height. And what are the dimensions of that? Well, I can count pretty easily. That looks like it's 3 high, and it looks like it's about 4 wide. 1, 2, 3, 4 boxes. Again, don't worry about what you see off to the left here. So to find out this hypotenuse, this top left side of the orange triangle, I would do 3 squared plus 4 squared, which is 25. Square root of 25 is 5. So this is a length of 5 here. As far as the other side, here's the right triangle for that. And that also appears to be a 3 by 4 right triangle. So that would be the exact same length right here. We would just do 3 squared plus 4 squared, like we did right here. Get 25, square root of 25 is 5. Okay, that's not too bad. So put these up here. We know the area of this orange triangle is 1/2 base times height. Since we just found that this length was 5 and this length was 5, the base and the height, we take 1/2 times 5, which is 25. Half 25 is 12.5 units squared. So that is the area for the orange triangle. Let's move on to the red circle. We are not too concerned about circles right now. We will be in January or February. But for right now, I can tell you that the area of a circle is pi times the radius squared, where the radius starts from the center and goes to the edge. That looks like a distance of 2. So we would take pi times 2 squared, which is just pi times 4. And we get about 12.566, which rounds up to 12.57. So this area is slightly bigger than the orange triangle, whether you believe that or not. It's slightly bigger. Again, not too concerned about that one for now. So then we move on to the green trapezoid. And I'm not too concerned about a formula for the area. You can notice that we left it blank there. We're more interested in seeing how we could maybe split up this shape into a couple of shapes we already know and then add up some areas. So what you may have saw was that we could potentially take that green trapezoid and break it up right here and here. Why is that nice? It gives us an easy rectangle in the middle and then 2 right triangles on the edges. So let's take a look at those area calculations. Overall, we would say that the area of this trapezoid is this triangle plus this rectangle plus this triangle. The triangles are each 1/2 base times height, and the rectangle is just its base times height without the 1/2. So then we go ahead and we start plugging in. And again, don't need to look on the left, just look on the screen here. The base and the height of these triangles, let me turn off this one. The base and the height of these triangles are 2 each. 2 for the base, 2 for the height. Same thing over here, 2 for the base, 2 for the height. This rectangle has a base of 4 boxes and a height of 2. So when we go and do those calculations, 1/2 of 2 times 2. 2 times 2 is 4. Half of 4 is 2. Same thing for this triangle. And this rectangle, I can see it's got 8 boxes, 4 times 2. So 2 plus 8 plus 2 gets me to 12. So that has a little bit less area than the orange triangle and the red circle. So that's the green trapezoid. And lastly, the blue rectangle. Notice that we know the area formula for rectangles base times height, but it's not easy to measure either the base or the height right away. So we will have to do exactly what we did with the orange triangle and figure out, let's say this is the base, let's say this is the height. Let's figure out the height and the base lengths by doing the Pythagorean theorem again. So we'll start with this bottom left side, and let's imagine that that's the base, and the bottom right side is the height. So we'll go to make our right triangles. There it is for the one on the left. And I'll do the one on the right at the same time, and then we'll do our calculations here. So this base here on the left looks like it's 3 high and 3 wide. So this is a right triangle with 3 and 3 as the sides, and I'm trying to figure out the hypotenuse. We always square root at the end. I'm going to do 3 squared plus 3 squared. 3 squared is 9, so 9 plus 9 is 18. So I'm going to leave this in the exact form for now. the base is the square root of 18. Do it like this. Square root of 18 is the base. All right, and for the height, go ahead and try this one yourself if you can. Looks like the height of the height is 2, and the width here is also 2. So this would just be the square root of 2 squared plus 2 squared. Square root of 2 squared is 4 plus 4, which is 8. So the square root of 8, that is our height of the rectangle. Okay, so again, back on our grid here, the area formula for a rectangle is just the base times the height. So if the base is the square root of 18 and the height is the square root of 8, I'm just going to multiply those two together. Square root of 18 times square root of 8, and that gets me 12. So this area is 12, trapezoid was 12, triangle was 12.5, and the circle was 12.57. So the circle was the biggest, cool for the circle, but the point of this was simply to practice using the distance formula to get some lengths and then using them for area calculations. Okay, that's the deal there. Let me turn all of these off, and we will move on to the next page in your grid, page 8. And now we're going to talk about perimeter. Which shape has the longest perimeter? There's only two choices here. We've got a green pentagon and a blue triangle. There they are. You think about the distance around the edge, and you probably think, they look similar. They're probably close numbers to each other. You can take a guess whether it's green or blue. We'll go ahead and start with the green. And I haven't mapped anything out here, so we're going to have to sort of do this visually. So I encourage you to maybe grab a pencil and a piece of paper and do this alongside me. Maybe graph this on a piece of graph paper if you have any, or just draw a graph. Let's think about the perimeter of the green shape. First of all, I see a horizontal segment right there at the top. That's going to be easy to calculate. That's just 2 boxes. So I'm going to start with 2. Now, for some of these slanted sides, top left here, here's the side, and it's slanted, so I'm going to think about doing Pythagorean theorem with a right triangle. And again, I'm just going to show you this with my mouse. If I make a right triangle for this segment, it would be 2 wide and 1 up and down. So side lengths would be 1 and 2, which means I'm going to do the square root of 2 squared plus 1 squared. And like the last problem with the blue rectangle, because this is not my final answer, I don't really want the decimal right now. Let's go ahead and do this simple calculation. 2 squared is 4, 1 squared is 1, 4 plus 1 is 5, which means this length here is the square root of 5. A little bit longer than 2 boxes, 2.23. That looks like it makes sense. So I'm going to add this original length of 2 to this length, square root of 5. Now notice if you're looking ahead here, this side here is also slanted, so I'd have to do a right triangle. It has the exact same dimensions. It's 2 high and 1 wide. And this one on the right here is the exact same way as well. It's a slanted segment, 2 high, 1 wide. So I've got 3 segments that are the same length, the square root of 5, the square root of 2 squared plus 1 squared. So what we can do with that is we can say, since I have 3 of these square root of 5 segments, I'm going to multiply it by 3. Just stick a 3 in front. So 2 plus 3 times square root of 5. Now for this last segment here, this is not quite the same. It is slanted though and diagonal, so I got to do my right triangle. If I imagine my right triangle here, looks like it's definitely 1 high and 1, 2, 3, 4 wide. So as a distance there, using the Pythagorean theorem, I would have 1 squared plus 4 squared. Let's think about that. 4 squared is 4 times 4, which is 16, plus 1 times 1 is 1. So square root is 17. Yes. Okay. So I'm going to add that to the original side, square root of 17. Okay, so 12.8 for the perimeter. Probably this blue triangle will have a similar perimeter. So let's take a look. Get rid of this work here. And for the blue triangle, do I have any easy sides to measure? Yes, I do. The one on the right that goes up and down, that is 4 boxes. No Pythagorean theorem necessary. The other 2, they look similar. They're both slanted. And if I were to do a right triangle, let's see, it'd be 1, 2, 3, 4 by 1, 2. So this right triangle has lengths of 4 and 2 for the legs or the sides. And the other side has the exact same thing, right? Goes up and down 2, 1, 2, 3, 4 to the side. So I've got this side of 4, but the other one, I can use Pythagorean theorem, and I know I'm doing the square root at the end, so I'll have 2 squared plus 4 squared. 4 squared, again, is 16. 2 squared is 4. 16 plus 4 is 20. So this should be the same thing as the square root of 20, and it is. And what else? We said that's this segment or this segment. I have 2 of them. So let's take that square root of 20 and multiply it by 2. The answer then comes out to be 12.94. So it turns out the blue triangle has a slightly longer perimeter by about 0.1 units. So that's how we use the distance formula for perimeters, where we have shapes on coordinate grids. You saw an example with areas where we tried to find bases and heights and then use them in area formulas. With perimeters, we are simply using the distances to add up the sides of these shapes, the lengths of each side. So we did that together in class, and then we spent time working on problems individually. So what you are doing for level 3 is, I have it written on page 2. So you can go back to page 2. You're going to answer the OST, that stands for Ohio State Test question, and at least 3 Khan Academy questions. So after you have watched this video, you're going to try out this number 31. This was on the spring of 2019 Ohio Geometry State Test. So it's pretty similar to what we just did. You're going to try that, graphing the points and then finding the perimeter of that triangle. And then I've got, I think, 7 Khan Academy questions, which is just a website that has good problems. We will use it at times this year, I anticipate. I'd like you to do at least 3 of these, okay? If you need help on them, please let me know. Whether it's in office hours, that would be great. If you want me to make a video, I can do that. But just let me know, and I'll see what I can do. I need you to do 3 of these for credit on level 3. Let me know if you have questions on the video, and I hope that that goes pretty well for you.